Hey guys, Miss Michelson here. Today we're doing topic 4 remediation, which is all about solving systems of linear equations and inequalities. So a system is going to be any time where we have a problem and we're given two equations. And we're just going to talk about some different strategies that we can use to solve these guys. So the very first question wants us to graph the solution to find the answer to these two equations. So we've got a graph over here. I am going to put a box around this first one in green, and then I'll do my second equation in a different color. Now, lucky for us, these two equations are given in slope-intercept form. So I know that this number here at the end represents the intercept. So -1 means I'm going to put a point here. And then this slope is 2, which means I'm going to rise 1, 2, and I'm going to go over 1. I'm going to rise 1, 2, and I'm going to go over 1. And then I can go down 2 to the left 1. And I can draw my line here. This green one, or this one I have in green, is a little bit friendlier to graph than this one right down here. I'm going to box it in pink just because of my intercept. My intercept's -7, but if I count down 1, 2, 3, 4, -7's off my graph. So I'm just going to do a little placeholder. I'm going to do 5, 6, 7. And I'm going to keep my pencil here, or my pen. This is my y-intercept, but it's kind of off the graph. My slope is -4, which means I'm going to have to go down 4 more units, but now I'm way down off the graph. So I'm going to do the opposite. I'm going to go up 1, 2, 3, 4, and I'm going to go to the left 1. I'm going to go up 1, 2, 3, 4 to the left 1. 1, 2, 3, 4. That one's off the graph to the left 1. And now that I got some points that do lie on the graph, the solution is where my two lines intersect. And I didn't do a great job of drawing this, but they intersect at this point right here. So I'm going to write that as an ordered pair. It's to the left 1, so that's -1, and it's down 1, 2, 3. So my solution is -1, -3. Now, there are 3 different types of solutions that we can have for these problems, and they all require, or we're going to sketch a picture of them here. So I'm going to draw an x and y axis for each of these solutions. And the first and probably the most common type is when we have one specific solution. That means we're going to have 2 lines, and their solutions are going to be where they intersect. So that point where they intersect is the solution. If they have no solution, that means our 2 lines never intersect each other. They're just side by side. They're parallel. And then if they have infinitely many solutions, that means that they are the same exact line. So my green line and my pink line are just going to be overlapping. They're going to be on top of each other. So if we ever graphed them, we would fall into these 3 specific cases. Now, this is a visual way of solving our equations, but we also want to have some algebraic ways to do that. So our first way to solve a system of equations algebraically is by substitution. And that is when one of our equations is already set equal to a variable, or it's in slope-intercept form. I'm going to take this equation right here. It tells me y equals 2x minus 10. And I'm going to plug that in, or I'm going to substitute that in to my second equation for y. So I'm going to have 2. Instead of a y, I'm going to replace it with 2x minus 10, and that is going to equal x minus 8. And the reason why this is an important, or this works for us, is because it got rid of my y variable. I only have my x's, and now I can solve my equation. I'm going to distribute my 2. Oops, I'm going to be left with 4x minus 20 equals x minus 8. When I have an x on both sides of my equation, I need to get them to the same side of my equal sign. So I'm going to subtract x from both sides, and I'm going to get 3x minus 20 equals -8. Now that I have 1x in my problem, I'm going to get it by itself. So I'm going to add 20 to both sides. 3x equals positive 12. And last but not least, to get x by itself, I'm going to divide by 3. X equals 4. Now, if we think about our solutions in our first problem, it's an ordered pair. So that's just my x value. I need to come up with my y value, and that is going to require us to plug this in to our first equation. We had y equals 2x minus 10, but now we know what x is, right? We know that x is 4. So I'm going to have 2 times 4 minus 10. This is something you can put in our calculator, or we can simplify. 2 times 4 is 8. And then 8 minus 10 is negative 2. My y value here is negative 2. We can write it as an ordered pair. Now, our next equation still asks us to solve using substitution. This time, they're both set equal to y. And in this specific case, when we have two equations that say y equals, what we can do is take these two right-hand sides, the two pieces that have the x's in them, and we're going to set them equal to each other because we know y has to equal whatever y is. So negative x plus 4 is going to equal 3x. And now we're going to solve our equation just like we normally would. When I have two x's on opposite sides of the equal sign, I need to move the smaller one to the other side of my equation. The opposite of a negative x is a positive x. So I'm going to add x to both sides. When I do that, I'm going to be left with 4 on the left-hand side. 3x plus x would leave me with 4 x's in total. And to get x by itself, I'm going to divide by 4. So we're going to get x equals 1. Remember, we can write that as our ordered pair. We found the x value. But now we need to find the y value. So I always it's like a two-step problem. This was part 1. This is part 2. I'm going to take either of these equations, and I'm going to plug in my x value. So I'm just going to take y equals 3x. Well, now we know that x equals 1. So y equals 3 times 1, which is just 3. So my ordered pair, or the solution to my problem, is 1, 3. So that is graphing and substitution. Another method that we have of solving a system of equations is elimination. Notice here that our equations are written in standard form now, where x and y are on the same side of our equal sign. And if we have things that have matching coefficients but with different signs, notice that this is a plus 1y and a minus 1y. We can use the elimination method to solve. And for elimination, what I'm going to do is I'm going to add my two equations together, only if they have the matching coefficients with opposite signs. X plus x is going to give me 2x. But negative 1, or this is a positive 1, plus negative 1 is 0. So that variable is eliminated, which is why we call it elimination. 7 plus negative 3 is positive 4. Now I've got an equation in one variable that I can solve. I'm going to divide both sides by 2. X is going to equal 2. My ordered pair is going to start off with the number 2. But just like in our last problems, we need to find our y value as well. If this is step 1 over here, step 2 means we have to take either of these equations. I'm just going to take the top one because it doesn't have any negative numbers. X plus y equals 7. But I know my x value is 2. So this x right here, I'm going to replace with the 2. 2 plus y equals 7. I'll subtract 2 from both sides. Y equals 5. And I can put that in my ordered pair. So elimination works when we have the same coefficient with opposite signs. If we look at our second problem here, none of these coefficients are matching up with each other, but I do have opposite signs. This is a negative 2 and this is a positive 1. So what I'm allowed to do is do a little bit of algebra to make this work. I want these two y's to have the same coefficient. So I'm going to take this whole second equation and I'm going to multiply it by 2. So I can get this y to be a plus 2y. And when I multiply this by 2, I'm really distributing, or I'm multiplying every single term by 2. So this is going to turn into a 6x plus 2y equals negative 24. So I just took everything and I multiplied it by 2. That's a legal thing to do in math. And then I like when they're stacked on top of each other here, so I'm just going to bring my first equation down. I had 1x minus 2y equals 10. So now that we have matching coefficients with opposite signs, let's go ahead and add our equations together. 6x plus 1x is 7x. 2y minus 2y is 0. The y's are eliminated. Negative 24 plus 10 is negative 14. Now to get x by itself, I'm going to divide both sides by 7. X equals negative 2. So I'm going to write my ordered pair, negative 2. I like to draw my line because I've split my problem up into two different sides. My second part of my problem that I need to do is solve for y. I'm going to take my first equation here, x minus 2y equals positive 10. I know x now is negative 2, so it's going to be negative 2 minus 2y equals 10. I'm going to add 2 to both sides to get negative 2y equals 12. And I'm going to divide both sides by negative 2. Y equals negative 6. So I can type or plug in a negative 6 in my ordered pair as well. So we've got graphing, substitution, and elimination. And then the last thing we're going to do is graph inequalities. So this is going to be similar to that first question that we did, except for where instead of an equal sign, we're going to have an inequality. This one is less than or equal to, but we're going to graph our line like we normally would. This is a negative 6, which is my y-intercept. So I'm going to go down on my y-axis to negative 6. I'm going to put a point. And then the slope of my line, which is going to help me find my other points, is this value here, 3. Remember, that is 3 over 1 as a fraction, so I can count up 1, 2, 3. And I'm going to go over 1. 1, 2, 3 over 1. And then I can also find some points to the left of my y-intercept by going down 1, 2, 3, and over 1. And before I draw my line, this is where my inequality statement comes in, or my inequality sign. If it's less than or equal to or greater than or equal to, it is going to be a solid line. So that's good. I'm just going to connect my dots with a solid line. And if it's less than or equal to or just less than, we're going to shade below the line. I always think about putting my finger on that y-intercept and I'm going to shade below it. If it was greater than, then I would shade above the line. For an inequality, there's not just one specific solution. There is a region that is shaded. Any point within this region is the solution. Now we're going to do the same thing for the second equation, but this one's a little bit more challenging because my equation is not in slope-intercept form. I want to get y by itself first before I can do anything. So I'm going to subtract x from both sides. I'm going to get negative 2y is greater than. These two are not like terms, so I'm going to write them side by side. Minus x minus 4. And then last but not least, I'm going to divide by 2, which means I'm going to take every term here and divide it by, well, I guess a negative 2. So I'm going to be left with y. Now there's one thing we have to remember with our inequalities. When we divide by a negative, our inequality sign switches. So we have y is less than. A negative divided by a negative is going to turn into a positive. So that's 1/2 x. And a negative divided by a negative is going to turn into a positive 2. This one is a little bit tricky, but we're going to follow the same steps that we did above. My y-intercept is 2, but notice the scale is going by 2s, so this point right up here is actually the 2. And our scale over here on the x-axis is going by 2s as well. So when I want to rise 1, I'm going to have to go like halfway up. And when I go to the right 2, I'm just going to go over 1. And then I'm going to go rise 1, over 1, rise 1, over 1, rise 1, over 1. Our dots are kind of close together here. And I can do the same thing on the opposite side. I'm going to go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. And once I have some dots written out, I need to ask myself, is it going to be a solid line? Well, this time I'm just a less than symbol. So if it's less than or greater than, it's going to be a dashed line. So it's not going to be solid. So I'm going to just do some dashes here. We can't connect that line, so we're just going to make it dashed. But it's still less than, so that means I'm going to shade below my y-intercept. So I'm going to shade all of this region right in here is the solution to my inequality. Now these two are singular inequalities. The last one that we're going to do is a system of inequalities, which means we're just going to take two equations and we're going to graph them on the same graph. Again, this one has a scale of 2, so we have to be careful. The first one I'm going to do in orange. So I'm going to go down 1, which is really kind of halfway between there, and it has a slope of 2, which means I'm going to go up 1, 2, and I'm going to go over 1. I'm going to go up 1, 2, over 1, up 1, 2, over 1, up 1, 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1. It's less than or equal to, so I know that I can do a solid line. And if it's less than, then I'm going to shade below it. That's just practice like the ones we did up above. Now, hopefully this one's a little bit nicer. The scale of 2 really isn't super great for these problems. My y-intercept is 3, so I'm going to go up 2, and then 3 would be halfway between 2 and 4. And the slope is -1, so I'm going to go down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Then I'm going to go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. And this one is greater than, and that means that this is going to be a dashed line. So I'm going to continue my slope through here. It's going to be dashed. And if it's greater than, we haven't seen an example like this, we're going to shade above the line. Now, it's important to understand what the solution actually is here. There's a region where there's no shading at all. There's a region where it's just orange. There's a region where there's just blue. And there's a region where it overlaps. The solution to our system of inequalities is only this overlapping region. So I'm going to highlight that in purple. This is the solution. Sometimes on tests like the ACT, you may see this written as like 1, 2, 3, and 4. And we would say the solution is region 3, the overlapping region. And that's going to be the last example for today. Now you're ready to take your remediation quiz.